Hello everyone, this is Lutz Elise. This is the part 3 no, of my series about mesh analysis. No? Let's give an example problem with solving for the current when the direction or assumption is to the right. So example guys, no, this is the diagram. So this is the part 3 series no, of my mesh analysis. So for instance, this is the diagram. So I have here a resistor, a voltage source. So for instance, the voltage source is 120, no, 120 volts. And then I have here resistor. Kana. And then another resistor here. This one. Okay. Then resistor here. And then we have a resistor between. And then another resistor. So for instance, the values are 2 ohms, 4 ohms, 6 ohms, 12 ohms, and then 8 ohms, 10 ohms, and 1 ohm. So I haven't yet given no sample problem no if the direction is to the right. So I'm going to share later on the Canyetes principle no. So like for instance, the problem is asking for the Ix. So solving for the current at 8 ohms. So the problem is find Ix. Okay. So by applying mesh analysis, this is the part of the series no of my discussion on mesh analysis. So same as usual no, we select saan ba dito yung mesh 1 mo, mesh 2 at mesh 3. So for instance, this is my these are the meshes no. So tatlo yung mesh natin. So I will designate this one as my mesh I1. This is my mesh I2, and then this is my mesh I sub 3. So solving for the equation. So at mesh 1, okay, so for the equation, so we have here a voltage source, so positive, no? So 120 is equal to, you are inside at mesh 1, so you put here I1. Sum up all resistor inside mesh 1. So the resistor are 2 ohms, the 4 ohms, and the 10 ohms. So you sum up everything, no? So this is 2 plus 4 plus 10. And then, for a while, ha? Delete ko muna yung naka-circle na red. Yan. So, 2 plus 4 plus 10. Minus, so there is the 4 ohm resistor. This one, the 4 ohm resistor is opposing to the other side of the mesh. So, we put here, wala na. Okay? So, we'll put here minus, no? Minus 4 I sub 2. And then the another resistor is opposing this one. 10 ohms is opposing to the other side of the mesh. Then you subtract again. Minus 10 I sub 3. I sub 3. Okay? And then solve mathematically, no? You simplify. So 2 plus 4 plus 10, that is 16. So therefore, my first equation is 16 I1 minus 4 I2 and then minus 10 I3 is equal to 120. So assuming this is my equation 1. Okay, so we're done with the first equation. So go through the second equation. Apply KVL at mesh 2, no, at mesh 2. Solve for the equation. There is no voltage source here in the second mesh, so we just leave it 0 equals. You are inside mesh I2, so I2 here. Sum up all resistor inside mesh 2. So the resistor inside mesh 2 are 6, 12, and 10, 4. So you sum up the three resistors or the three values, no? 6 plus 12 plus 4. Then if there is a resistor opposing to the other side of the mesh, so the 4 ohms and the 8 ohms opposing to the other side, so minus 4i1 and then minus 8i sub 3. So just arrange the equation from I1 to I1, I2, and I3. So this is negative 4i1. So 6 plus 12 plus 4, that is 10, 22, no? Plus 22 I sub 2 minus 8 I sub 3. So therefore, then equal to 0. So this is now assuming this is my equation 2. Okay, so we're almost done with the three equation. Solve once again the third equation, refer to mesh 3. So with this mesh 3, so there's no voltage source in mesh 3, so 0. I sub 3, sum up all resistor. So for this mesh, no, there are 3, no, 8, 1, and 10. So i-add mo yung tatlo, 8, 1, and 10. So you can solve it directly, no, but I just show the solution, no, for those na will check, no, para mas madali nilang ma-understand yung solution ko. So you add 8 plus 1 plus 10. And then opposing again the 8 ohms and the 10 ohms. So minus 8 I sub 1, I sub 2 minus 10 I sub 1. So therefore, negative 10 I1 minus 8 I2, okay, plus 8 plus 1 plus 10, that is 19. 19 I sub 3 is equal to 0. So this is now my third equation. Okay, so we're done with the three equation. So solve for the values of I1, I2, and I sub 3. Okay, so solve for the values of I1, I2, and I3. Three equations, three unknowns. So I'm going to input the value, no, using my calculator. Right, so for a while, so for the first equation, that is 16 I1 minus 4 I2 minus 10 I3. So you input the values, no, using three equations, the unknown. Okay, equation. Alright, so 16, and then, sorry. One. Okay, so 16, negative 4, and then negative 10 was, teka muna ha. Sige, 16, negative 4, negative 10, negative, negative negative 10. This is 10. 120. Tapos, negative 4 equals, kahit sa factor 22. And then negative 8, negative 10, negative 8, and 19. So 16, negative 4, negative 10, 20, negative 4, 22, negative 8, 0, negative 10, negative 8, 9, and, oh, I mean 19, then siya 19. 19, 0. Okay, so the values are the following. Your I1 is 118 over 7. 7 ito 7. Okay? Tapos, 52 over 7. And then 12. No? 12. So, this is very nice, no? 12 ampere, no? Ampere. Right. So, the problem is asking for the I sub x. So, I'm going to share my Canyotis technique, no? So, like for instance, no, that example, no, the assumption of current is to the right. So, Canyotis principle says that, ayan, remember this ha, principle ha. So, if this is my mesh I sub 2, we just apply in the example ha, para mas madali. And then, this is mesh 3. So, by applying Canyotis principle, if the direction of the current is to the right, to the right ha, to the right. If the direction of the current is to the right, your I sub, for instance, Ix, no, is always your I mesh downward. So whatever be the mesh downward, for instance, this is I3, then you subtract with the mesh current downward or upward. So down minus up. If the assumption is to the right. So in this example problem, we apply here, we apply the Canyotis principle. So this is simply, since to the right, Ix is just equal to I sub 3 minus I sub 2. So if the direction assumption of your current is to the left, so for example, to the left, no, instead of to the right, so by Canyotis principle, Ix should be I mesh current upward minus I mesh downward. So, baliktad din. If the assumption is to the right, this one, down minus up. If the assumption is to the left, up minus down. Anyway, once you have a negative values, so it is an indication that your assumption is wrong. It should be on the other side. So we will check muna if the value is positive. So probably if it is positive, so the direction of current is correct. So your I3 here is 12 minus 52 over 7. So assuming wala tayong mali sa calculator side, no, in solving for the three equations, then we subtract 12 minus 52 over 7. So 12 minus 52 over 7. So more or less 32 over 7. Okay? 32 over 7. Ay, sorry. Yan. 32 over 7. No? 32 over 7 ampere. So, i-review ko muna ha before ko i-end yung video ko. So, more or less, this is the final answer. The value Ix is 32 over 7. Check ko muna once again no, the three equations before ko i-end yung video. Hopefully, nakatulong yung tips ko ha. Okay, so check ko muna. Ah, may kulang pala no. So may kulang pala tayo sa mesh 2 no. We have a wrong here no input. Hindi ko sinali yung 12. So in this side, this one. In the mesh 2 no. If you notice 6 plus 12 plus 8. Hindi ko nasama yung 8 no. So I just delete this one in the mesh 2. This one ha, this one. This one. Kulang. So it should be 6 plus 12 plus 8 plus 4. So your value here should be a total of 30. Sakto? 30. So 18, 26, 30. So this is not 22 but rather 30i2. So this is 30i2 minus 8i3. Okay. No, negative 8. Tapos 0. For the equation 3, negative 10. Okay. So decimal pala yung value niya, no? Delete ko muna ha. Okay, this one. So delete ko muna yung mga value niya, saka yung ix. Okay. So therefore, I1 14.62 and then 4.5 551, and then lastly 9.60 or 60, 99.6. Okay, so 60, -4, -10, 120, -4, 30, -8, 0, -10, -8, tapos 19 equals to 0. So, tama na ito. So, you can also use the fraction, no? If you want, if it is in terms of fraction, no? So, this is 25, 30 over 173. And then this one, ilit ko muna ha, ang ix. Mas maganda kasi pag fraction, no? So, 25, 30 over 173, tapos 780 over 173, and then finally 1660 over 173. So your ix should be I mesh down minus I mesh up. So ix is simply I3 minus I2. So that is 1660 over 173 minus 780 over 173. So, yung ix ko is, my calculator, dyan ha, wala kasi akong calculator dito. Naiwan ko. So, you just simply subtract ha, 1660 ha, by 173. I mean, 780. So, more or less 880, you know? 1660. 5. Okay, 5.1. Okay, so the values are, the value is 5.09. 5.09 ampere. So, this is my final answer. So, just check no using calculator. Importante na na-follow nyo yung procedure ko, no? Again, do not forget the Canyetes principle. If the direction is to the right, down minus up. If the direction is to the downward to the left, then that is upward minus down. If the direction is downward, left minus right, no, from the previous video, no, then if the direction is to the left, then right minus up. So I hope nakatulong, no, for this problem. So hope to see you on my next, no, series, no. It's more on the superposition probably, or other theorems in electrical circuits or DC circuits. God bless everyone, and continue to follow, like, and share. Follow my Facebook account, Larry Angelo Canetti. Also my YouTube channel, no, Larry Angelo Canetti. So just practice, lang din practice, no? Practice makes perfect kasi. Constant practice lang talaga yung secret.